Yo, 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 what's up? Happy Friday, everybody. And yes, it is circle time again. Devioli, what's up? How's it going with the SRP? Can't wait to be done with shaders for now. What? Shaders are so fun. What's up, Cooler SK? Chilled, was busy last some days, couldn't join you, sorry. No sweat, no sweat. Thank you for stopping by, appreciate it. I'm me. You're going to finish Dr. Circle today. That's the goal. Hopefully. And Fabic, what's up? Early morning, or haven't you just slept yet? And wake up, write some code before you put your makeup on. Yeah, I think that's the line. I think that's the line they are singing. Definitely. Let's see here, Devioli. I just need to figure out how to write the result of my shader into a temporary RT so I can use that in a second pass. Oh yeah, I've been doing that a lot. I've been doing it for the outline shader and also for the apparel system. It actually worked pretty good, but good luck. And Cooler SK waiting for my motherboard should arrive today. Ooh, happy times, happy times. So I assume you are gonna game the whole weekend then. Cold Bones, yo, yo, yo. Cool circle, what's it for? It's gonna be used to mark vertices we're going to change in the terrain. But like, the more I think about it, like, instead of just changing all of these vertices, the white ones, we just want to change the ones within the circle. And I'm not even sure we will save that much time by skipping these, because we have the overhead of the circle algorithm. But we're gonna find out. No sleep. Sleep is for the weak. Yeah. Fucking wish I could agree. What would you say if I told you, sir, that I converted float nodes valued to bytes? So instead of representing your terrain values by float, you represent them by bytes. Am I reading that correct? That sounds like... So did you do it by float 32s before? That should save you a lot of time. Or... if it doesn't come with visual artifacts, I guess. Cooler SK is feeling weak. Yeah, sleep is like my... what is the saying? Achilles heel. I do need my sleep. Devioli, yeah. So what I did with my outline shader is I used the Unity render feature API, and I don't know how much that has changed in the later versions of Unity, but yeah. Much less data to hold. Yeah, I assume so, Fabic. And have you noticed any visual glitches? Like when you lose precision on the graphical side, you usually also get some small artifacts. Depends on what you lose precision in, I guess. No glitches. Nice. That's fucking great. Nice. Okay, so I'm almost at the point where I get anxiety just looking at this circle. But let's see. So I think everything works like perfectly fine as long as the circle is located at Origo. We get some glitches when we move to the right and left, but these glitches are... So we know that the glitches are origin, or depends on the origin offset. We don't know exactly why though, and we can see here also, like the glitches are... We get a little bit of a wrong result here. So the bottom looks okay, I think. Fuck, is this correct? No, I think this one should be marked. It should be closer to this one than this. And yeah, this one should be marked, this one should be marked. So yeah, let's see. Let's see if we can fix this. Yeah. So I reckon I had to run yesterday, as usual, in the middle of things. But I think... I wonder if it has to do with... So when we get the next point, when we figure out which point we should go to next, we do it by minimizing the radius error. So my guess is that the problem lies within these methods. And right now we handle the origin error like this. Or we handle the offset like this. I wonder if... I don't remember if we tried it yesterday, but maybe we shouldn't have the truncated offset here. I'm just not sure. Does it make sense or doesn't it make sense? No, I think we want the actual position right. So I think this makes a lot more sense. But then again, no, wait here. So we want to check the error of this segment point. So this is a truncated point, basically. Yeah, I'm pretty sure we want the... So we have a point on the circle. We have the point segmented, so truncated. I just want to see what kind of result we get if we don't truncate the origin as well. Although I'm very skeptical that it will fix the issues. But my skepticism was probably unfounded. This looks to be all right. And this also shows... Yeah, this looks alright. And by looking on this, we can see that we cannot mirror the circle. So it's not enough to just do the top and then mirror it. Because depending on the offset, we get different truncated errors. Like this looks all right, or this looks correct, right? If we take a look at each point, the points marked are the ones closest to the circle at every point, right? So if we have this offset, for instance, on this side we get a straight line like this. On this side, however, we get 2 points over here. Very interesting. Very interesting. Or is my bar for what's interesting low? Maybe, I don't know. I think it makes sense. So, but then, okay, and here we have a not correct result. Fuck, this one is making me insane. Why are we getting this? Okay, is this... Are we pretty much right in the middle of these 2 points here? And this is just and this is just a floating point error. Can you snap the circle to the nearest point? I guess we could do that, but yeah, we could. This is very weird. Yeah, this is wrong here. Fuck. This one is making me nuts. What do we have? Oh, but it's probably... Is it just the starting point that gets screwed up? 0.85. Is it just the starting points? Because if it's just the starting points, then I might know what's going on. Okay, so it's the starting point to the left. So yeah, yesterday when we did the starting point here, we might have screwed up. So start position, origin, yeah, so I think it's this problem right here. We don't want to... We want to add offset before we truncate it, basically. Let's see, can you snap the circle to the nearest point? Can you check, sir, if you move the circle and place it on another point to see if the shape is the same? It should be. Okay, let's try it. So if we go to 0, 0, 0, we have something like this, and let's see here, we have 30 segments and we have a size of 3. So what is that? 0.1. 0.1. Now we get an issue here, but that one I think we can solve. Yeah, So let's fix this issue first and then look if everything looks okay. So the issue we have there is that we calculate a start position here, then we truncate it, then we add a truncated offset. We want to add the offset before we truncate it. So basically we should be able to do origin plus radius, start position, yeah, let's do it like this. Start position, can I change? Ah, beautiful. Start position right, and then we do start position left, and instead of going plus here we can do minus, or we could just do left. And we don't need to offset it, so that's for the third one. We want to do the second one as well. Start position right, and start position left. Okay, now let's move it 1 point and see if we have the correct result. Fuck! How did I screw up this bad? Ah, yeah, you're true. Thank you. Great. Great catch. Beautiful. Okay, good start today. So it's this one that is wrong. Start position left. Oh, yeah. We don't want to offset it twice. Okay, so this should be it. I sure hope so. There we go. And now if we just move it 1 snap. Ooh, okay, but this is probably because of a rounding point error, right? So when we round it, so what is the round? If you round a float and you want to get it to the closest integer or closest step, if it's even, you take the upper one. If it's odd, you take the lower one, or something like that. So that could explain the difference we're seeing here and here. But if we jump 2 steps, we should see this. Okay, so that's not it. My guesses aren't going very well today. It seems like for every point outside of, here we have, if we take plus, Okay, 0.1, 0.2, 3, 4, 5, 6, 7, 8. If we do 7 here, we get a problem. Good morning, Harukanan. Is it consistent every other? You can't see clearly on the stream. It varies a little bit, but like I think we're seeing the correct result here. Like I can't really find a point or a case where we're not getting the correct result. Maybe this one. It's extremely hard to see. Like, is it... I could buy this one as well. Could write a test here, like where we... I don't know. Do I want to write a test? We could write a quick test where we just go through the circle, the correct circle, and we do it with delta degrees, and for every delta degrees we check the closest point. Fuck. Question is, why wouldn't one just go with that solution from the start though? Couldn't you just... but you might miss points and so on. Okay, I get it. But let's see if we can make a quick result here. So, or a quick test. Oops. Let's do this, and then we do... Yeah, exactly. Let's see. Draw. I would like to call it truth, but oops. Yeah, maybe. Draw circle 1. Let's do private void draw circle 3, and we do if draw truth, draw circle 3, and in here we just do for float t is equal to 0.0f, t less than or equal to 1.0f, zero point 0.05, vector 3 start direction is equal to, I guess it's vector 3 dot forward, so that's up, right, in the Z, yes, so that's start direction, and then we do vector 3 position is equal to origin plus start direction, but we want to multiply it with radius, so then we get a point on the circle, and then we want to truncate this one, so vector 3, let's just do position is equal to what is it? It is position.x divided by delta, round that one, and then multiplied by delta 0.0f, and I'm going to do the same here. But with Z, and then we do. What's up, Wesley? Watching a couple of days now, lurking. Appreciate it, but it seems like the end is near now. Yes, indeed it does. So I guess also the reason you want to go with this approach is you never do any unnecessary steps here. Doing this one, if you have a too big of a delta, you might miss points. If you have a too small of a delta, you might be doing it multiple times for the same point. That is my initial thought now. I don't know if that's the case. The end of the journey of the circle, yes. But a new adventure will start for this circle, I promise you. Although I have my thoughts about it ending up in when we have the circle approach and when we have the square approach side by side and we compare them, I'm leaning against there not being that much of a time difference or performance difference actually. But I've learned quite a lot, so yeah, no loss, no loss. Okay, let's draw a sphere here. So we're gonna do gizmos, draw sphere, position, and for this one we're also gonna do color is equal to color dot black, I think. Oh, come on. Once one thing is done, there are two more tasks. Yes, definitely. It just needs to work for your implementation, not for every edge case scenario. That is also true. I think this should be the ground truth, basically. We're gonna make this a tiny bit bigger so it overrides. I doing it too much here? Maybe. So if we do draw truth, oh yeah, one thing, we also need to rotate this one, right? So we have a start direction, now we need to rotate it so we get more points. And we want to rotate it by T. And we're gonna do that by doing start position, or start direction. Let's just call it direction. Direction is equal to creates a rotation which rotates angle degrees around axis, but if I remember correctly, we didn't need this one. Instead, we could just go with, what is it, Euler angles, I don't know. And we do 0.0 f, and this is in degrees, right? We're just gonna get a half circle here right now. Or maybe not. Fuck that. Let's change this one back to start direction. And then we do vector 3 direction is equal to start direction. Direction is equal to this one, and here we do T times 360, I think, and 0.0 f. So this is a rotation that rotates around y by t times 360 degrees. So we multiply this one with start direction, and that should be correct, right? And then we want to use direction as well. We're going to use it here. What? Is my step this bad? 0.05? Or am I misunderstanding something? "100 steps." Now we should definitely be seeing more. Ah, there we go. Truth. So there's a tiny bit of a difference here, a tiny difference. So we get this point, this point. Same up here. But ground truth, we can see here that the lower doesn't match the upper one either. So we get some additional points by doing the ground truth, and they are always located. Are they always located here? But, like, the question is, we probably don't even want these points, right? So if we check at this point, how do we? I don't know. Gustav, thank you so much for the follow. Appreciate it. Ooh, I don't know. Nah, I don't think we want these points, to be honest. Let's see. So this ground truth is basically, we're going the other way around, right? So we take a point. I'm trying to make this make sense. Get additional points with the solution. But why is it so? In this solution we go along the circle and we always find, at any point of the circle we find the closest pixel. Wouldn't really call it pixel, but yeah. So for each point on the circle. In the other solution we loop through pixels, always minimizing the error. Is it the same problem you had with left and right side? I don't know. But I think, let's see here. We had some case where we got one simple pixel. Here, let's see. Can I get it again? There we go. What does the ground truth write here? It writes pretty much exactly the same. So the only difference is we get some additional points by doing the ground truth. We never lose points or change points, I think. So, this just feels a little bit better. So, does it make sense if I think about, so this, let's take a look at this pixel right here, first of all. This one is included in this solution, but not in this solution. Actually, yeah. And that's because in this solution, the black one, we go along the circle and we all at certain steps we check for the closest pixel. That's how we do it. For this solution we always go from pixel to pixel and only in two directions. So it's basically oh yeah. Well, I think I want to know more. I want to get to the bottom. Like, I want the objective truth, if there is one. But I don't know if we're gonna spend more time on this. Like, this solution way less performant, and we get some additional points we don't care about, I don't think. Like, the thing I was most worried about was like the difference here. We can see one pixel here. It's a little bit weird, but it turns out it's correct. So, do I dare take the next step here? I think so. We're gonna keep the draw truth because it's a nice comparison to always have. Okay, I don't want to clean this up just yet because now we're gonna do a new thing. So the fact is we're always moving. We have 4 different segments. It's actually 8 different segments, but we have paired them, so we have 4. We have the red one, the yellow one, the green one, the blue one. And that doesn't really matter. Like the best way to think about it is like we have 2 segments. We have the left side of the circle and we have the right side of the circle. So I'm trying to visualize parsing the circle that way. Although, oh well. I'm splitting it up into 2 circles divided on the vertical line because like the whole purpose of this circle, we're getting these points, is that we care about, for each row we care about minimum and maximum. So we want to loop through each row, get the minimum, the maximum, the minimum, the maximum, and so on and so on. And what this has shown me as well is that I was wondering, so look at this. This is the start. Like I'm wondering if will we have a case where this side drops a row before this side drops a row. That's very important. I don't know. What is it? Shift? No, control. Alt. Okay. Yes, here. Okay, so this is gonna screw us up a bit, where we won't be able to rely on the algorithm always switching. Like it won't be possible to rely on both sides switching row at the same times. So that's what we're gonna have to keep in mind as well. Because here we can see, I think this is the starting point. We go on the left side, we go 1 step to the left. On the right side, we go 1 step to the right. Then on the left side, we go left and down. While on the right side, we just move to the right again. Okay, this sucks. So draw circle 1 is the one we're going to rely on. So this one most likely not possible unless I've gravely misunderstood something. Okay. Draw octant. I think I would like, we want to have a start point. Okay, I'm thinking about how I want to implement this one. I might want to simplify stuff now. I might want to introduce additional structs and classes and such. But when it comes down to it, in the end, we want this one to be quick. So the introduction of a lot of those things might be a little bit excessive. But fuck it. Let's do public struct I do actually have a struct called range, although it's currently float only, and we would like int here. Let's see, public struct octant parse data setup. Start point is probably a good way to go about it. I want to call these, I want some logic to this one. So always when you parse an octant, you have a primary direction and a secondary direction, or I think they refer to them as fast. The primary direction as fast in the Wikipedia article. So primary. Okay, let's see if this one can create the okay. Come on. And then I wonder, start point truncated, now we do delta. And when it comes to, let's see here, we have origin. Do we have origin truncated, but do we use it? Yeah, we do. Yeah, we use it in angle. That's definitely true. Oof. We wanna, Fuck, are we doing the correct thing here? Yeah, we might wanna... Yeah, we might just wanna use... Or actually, angle check, start point, current point. Yeah, start point is actually truncated, so is direct current point. So yeah, we might want to check truncated origin here, actually. But then again, get next point. I also know that there should be a cleaner way to compare, like instead of checking angle, you should be able to check X and Y, if, or X and Z in our case, if X and Z is the same. Oh yeah, we can optimize it like this as well, but yeah, let's wait with that one. Yeah, okay, so here we have it. So only one accent and then reflect it, but what if... Okay, so I'm screwing up somewhere. But then again... Or is this just a case for... Or, like, is the symmetry only a thing if... Yeah, the symmetry is only a thing if we constrain origin to... Okay, if we constrain origin to be equal to always truncated. So if we truncate origin, then we can rely on symmetry. And there's no reason whatsoever not to truncate to origin. So yeah, if we rely on origin, we just need to calculate 1 octate and then just fucking flip it. Right? So we only destroy the symmetry when the origin is not located at one of the vertices. Okay, I'm okay with that constraint. I'm like, the thought of... Okay, so I'm just visualizing here that the player has this terrain marker floating along the terrain, and I like the idea that it always snaps. And that's basically what we're gonna do. So we always snap it. We always truncate the position of the marker. And then we let the float or the radius be a float value, but that won't result in non-symmetry. Okay, like fuck, I'm second guessing myself all the time, but that's true, right? So here we don't have symmetry on the vertical axis. Like, this side is not the same as this one, but that's because we have an origin that is not truncated. But then again, let's see here. Okay, I want to try this. So let's start by truncating origin. So we do we calculate it here. We have origin truncated. And that's true. Okay, let's just move this one up to here and change it. Remove this one and rename this one Origin. But fuck it, I like the name Origin Truncated, so yeah. And then we want to draw the Y sphere here, and we have start position. And yeah, we have origin here as well, but it should be okay now. And now it snaps. And we get symmetry, which we can use. So if we just calculate, I guess it's this one to this one. How do we want to flip it then? We want to flip it. Okay, if we get this octate, we can just flip the Z coordinate around the origin, and we get these. And we can flip them around, those two around the X coordinate, and we get these. And what then? Do you rotate or? Yeah, do you just rotate it? Oh no, you flip it, or you mirror it on the 45-degree. How do you do that in a nice fashion? Mirror it around a diagonal line. You basically just swap. Okay, I think it can be doable. I'm just gonna run AFK real quick first, and then let's dive into this. Okay, backstory about that. Okay, but this makes a much more sense. We can get some performance out of this. Like, my big question mark is just... we want to flip. But actually, now when I think about it as well, if we truncate the origin... fuck yeah, if we truncate the origin, we just calculate it as if the origin was 0, 0, 0, and when we have all pixels... we just offset them, right? Fuck, I should have read this one a little bit more thorough. These steps are basically probably explained here. But yeah, okay, that's nice. So we just draw the circle around 0, then we offset the points when it's done. That's great. We just need one octet. So let's create a function that we don't need those structs I started to work with. We just need a function that returns these points, and then we fucking mirror them, and we're done. But I'm trying to... the thing is, we do want to apply this later on to... okay, so this is the pipeline. Like, we have a position in the world, in world space, a float position, and a float radius. We truncate that position to the grid, float grid, and that's our origin, but we wait with that one. And then based on radius, we calculate X number of points, and then we mirror those points, each point 8 times, I think. So we're gonna get duplicates. We need to keep that in mind. So then we have 8 times X points, minus duplicates, of course. And then we can offset all of those points, and that are our floating points. Or actually, before we... I need to write this down. Let's do circle selection to terrain indices. Approach. And then we're gonna have two different here. We're gonna have square approach, and we're gonna have midpoint circle algorithm. Is that what's it called? Midpoint. Can we do a numbered list like this? Is this how you do it, or do you do it like this? A, B, yeah. calculate given a point in world, we want to get indices how is it you do this? Indices we want to get them like rows, so indices indices. DevBB, what's up? Thank you so much for follow. What are you aiming to do? Just color the spheres on a circle? No. So given a point in the world and a radius in world, we want to get indices of our terrain. So we want to map. It's quicker to just show. So basically it's all about mapping. So given a pointer in world, given this marker, we want to get all the indices of the vertices making up the terrain that are within the circle. So that is the from start to finish what we want to achieve. And this is originally an algorithm for rasterizing a circle, but we want to use it to calculate exactly which vertices are within the marker. So yeah, midpoint circle algorithm approach. Given a point P in world, that's the marker. Marker point P in world, we want to get indices. How do I want to express these indices? So we want to get them row wise, so I want to do this. I don't know if it's supported here. Row. Can we do this? Row X. Now let's just do in the C index X. Fuck, does this make any sense? 1, 2, 3. No, okay, I made it wrong. Let's see. X and 2. Let's see, we want to get indices. X1, 2 indices, X1, I don't even know what I'm doing anymore. Indices X1, oh, it's actually not too bad. So what I'm trying to express here is that we want like this, I think. Yeah, what's up, Cypher? Okay, so I think so. Midpoint circle algorithm approach, given a marker point P and point P and a radius R in world, we want to get indices of terrain vertices within circle within the circle formed by P and R. Is this a good way to put it? I think. Given a marker point P and a radius R in world, we want to get indices of terrain vertices within the circle formed by P and R. Yeah, that's the goal. And the approach truncate P to truncate P based on terrain grid. Calculate X. Can I use X here? Yeah, points. Calculate X points terrain points, making up the first octant of a circle circle with radius r located at terrain origin. Would like to say terrain patch origin, I think. Truncate P based on terrain grid. Calculate X terrain points making up the first octant of a circle with radius R located at terrain origin. Is this making any sense? Yeah. Hopefully. And how are you doing today, by the way, Cypher? Having a good Friday so far? I think the next step I want to do here, or actually, before we mirror these points, do we want to delete the ones we don't need per row? So for here, for instance, for this one, would we delete this one, this one, this one, and this one before we mirror them? Or is that... That's a very fucked up thing to do, because if we mirror them, then we lose a lot of points here. Okay, so we want to mirror them first, and then we delete. What do I want to call them? What do I want to refer to them to? Then we delete points inside the outer points. Then we delete intermediate points, maybe. Okay. Mirror, calculate X terrain points. Mirror the X terrain points per 45, is it degree? Line to get the points to get all the points to get the points for each octant. Beautiful. Remove intermediate. Intermittent. Is that the correct word? No. Intermediate. Ah, beautiful. What's up, Ligab 12? How are you doing today? Intermediate points only keeping points at the ends of each. Start and end of each row. I'm pretty sure, almost entirely sure, that we can skip. So right now we have calculate X terrain points. So we calculate the points. So we're calculating the points like their world space position. I'm pretty sure that we can start calculating with the points using their indices in the terrain from the get-go. So we might skip a last conversion where we convert them from world space points to indices. I think we can do this. But let's see here. Remove intermediate points, only keeping points at the start and end of each terrain grid row. Order the points as start point and end point pairs. And finally then convert remaining points to indices. Truncate P based on terrain grid. Calculate X terrain points making up the first octant of a circle with radius R located at terrain origin. Mirror the X terrain points per 45 line to get the points for each octant. Ooh. Can we do 4 1 2 A, remove duplicated or remove shared points, duplications between octants. Remove intermediate points, only keeping points at the start and end of each terrain grid row. And unfortunately, this is also only for the most straightforward way where we're not when we're in the center of the terrain patch, so we're not talking about, we don't need to check for if we're outside of the terrain. I'm ignoring that for now. Okay. How do I want to move forward here? I think what I want to do first is this. Definitely want to get this. Or first we're gonna make, actually we want to do this, we want to do this, we want to do this, and then we want to do one more thing here. Offset the points using the truncated P Yeah, okay, so what I want to do, I think, first is we want to calculate everything without offsetting it. So yeah, we haven't really done that so far. And then we offset it at the end. So we get that to work, and when we have that working, we alter our functions such that we only do one octant, and we return the points from that octant, and then we try to mirror it. And when we have that in place, and we've got that in place, we will do this one, and then we will do this one, then we will do this one, then we will remove the offset and add it after everything. I don't know, we'll see. Devioli, I got it, I finally got it. Oh, nice. I hope it's efficient enough for a post-processing effect, but it's enough for showcases, I guess. Nice, feel free to share the result if you want. And congratulations for solving it. Okay. So let's start by, so we currently have this. We aren't creating this by symmetry. That's the first thing we will do after we alter the offset. So right now we offset the point and then we calculate everything. Right now we're just going to calculate everything, then we're going to offset it based on a point. Do I need to keep this solution? I don't think I do. We have this one actually, so fuck it. Now I got the area for the effect. Now I can make the effect, something I feel more comfy with. Okay, so this was like the first step towards a nice end result. Okay, so I probably want to skip this one actually, but let's see here. The idea is that we do origin truncated here. We use it on a lot of places. Start position here. Let's remove that one. So we do radius forward. We just remove the origin. We do it here as well. Here as well. We do it here. This is so nice. And then we do, when we draw the sphere here, we do current point, we do truncated, origin truncated plus current point. And we want to do it here as well. Okay, yeah, let's just comment this one out for now. So the difference now is that we calculate all points as if we were doing it around the origin and then we offset it. Makes sense. But I don't know. I will send a screenshot or video into your Discord once I'm done. Nice, looking forward to it. 0. Okay, so now we got this working. That's nice. Next. So yeah, now we have postponed this one to right before we draw them. So let's do this one. So draw circle 1, comment this one out as well. Where's this from? Okay. Just a loose... Or... The fuck? This one is paired to this one. Oh, okay. I see. Okay, so first of all, I want to create a function here, private vector3. Let's return a list because we don't know how many points it will be. So calculate octant points. And I do wonder, so in the Wikipedia page I think they use the yellow octant here, so the right one, and I don't really know if there's a difference or if one is better than anyone else. But I guess it's natural to begin here. That's usually what you begin with when you draw a circle with cosinus and sinus, right? That's usually how it goes. So this is 0 degrees, this is 45 degrees, this is 90 degrees. So yeah, let's start at 0 degrees. So we pretty much want to do... Okay, we draw 2 octants here. Let's take this one. We move it here. And what do we have? We have set color. We're gonna skip that one. First of all, vector list vector3 points is equal to new. We do figure out the start position, but we're not going to figure it out. We're going to do radius times vector3 right. And start position. Yeah, then we truncate it. Yeah, and then we call draw octant, but we don't want to do that. We want to do, let's see here, let's take a look at draw octant. So just this one, let's take all of this and let's move it. We can figure out delta soon. So we have start position, current point is equal to start position. Yeah, we're leaving this failsafe here. Angle check less than or equal. Which always check it between start position and current point. Start position. Start point, current point. We check 45 degrees and then we draw it. We add the origin here. We're gonna wait with that one. And instead we're gonna do points dot add current point. And then we get next point, and we need directions here. So the directions are always going to be the same. So let's start it up here. And we do direction primary. It looks like I can't really decide if I want to go, like if I want to name it current point or point current, or if I want to name it primary direction or direction primary. I just have to choose one and be consistent. For now, we use start point and current point, so let's do direction. I mean, let's do primary direction. So if we begin in this, at this one, so our primary direction is straight up. So that is 0.0f, 0.0f, and delta. And our secondary direction is up and to the left, so minus delta. So these should be our directions, and then we just do primary direction, secondary direction. That's about it. We add the point, we don't do anything else. And finally, return points. But, oh but, now that we are centered around origin, like we always calculate these octant points and we just do it for one octant, it's always around origin, and on it goes. Then we can probably, instead of doing this angle check comparison, I would like to replace it with because of the continuity of a circle and because the maxima along both axes is the same. Let's see. What am I looking at? Looking for? I'm looking for a different way to end this while loop. And I think I read that like we should be able to quit when x and y, or x and z in our case, are equal. There we go. It extends both ways to reach the nearest multiple of 45. It can determine where to stop because when x it has reached 45 degrees. But yeah, that is true for the first octant, right? If we do this way, when y is equal to x, we stop. And when we previously calculate, or when I previously calculated each octant on its own, then this is not true anymore, because when we're on this side we have a positive x, positive y, negative x. It's true for this one though, negative x, negative y, but it's not true for this one, so only this one and this one. So I think we can rely on this one again. Halil Sinasjon. Sorry for the pronunciation, but thank you so much for the follow. Appreciate it. Yeah, let's try it. The good thing is that we have our failsafe here, so we will never loop more than 100 times. Angle check less than equal, but but we do need to remember that we're not working with an integer grid, we're working with a float grid, which means that we want to rely on a coordinate check here, so which we implemented previously. We want to compare floats using an error. So float 1 minus float 2, this is the exact comparison we want to do. So we can just do coordinate check, I think. One sec though. Yeah, so if coordinate check is true, this one is equal to this one, then we quit it. But yeah, we're gonna miss 1 point currently, I think. Just in the way our while loop is structured, because we add the point, then we calculate the next point, and then we do the check. So if we calculate the next point and it's the 45-degree one, this check will fail and we will jump out. We do want to include that point, but let's keep it like this for now and just keep that in mind and do the change we need to do later on. Coordinate check. So let's see here. If they are equal, this one returns true. So while coordinate check on current point with an error of, I don't even know what I want to go with here. 1, maybe 0.01. While this one is not true. So while x and z are not equal in current point, we continue. Okay, so calculate octant points. Let's do this. And let's just add a for each point in points. Gizmos, draw, or actually color. Let's go with red again, and we do. I want to draw them like. I want to draw them without the origin, first of all. We're going to add that one back later on. Point. Ooh, probably missed something, but let's see. Points, calculate octant points. What we do in octant points is we create a new list. We get the start point, which is just origin, world origin, plus, so 0, 0, 0. So then we have radius and to the right. Then we get the start, or then we truncate the start point, make it snap to the grid. Because if we do, we can rely on symmetry. So this is like a big note. I might want to write this down somewhere. But I don't know where just yet. Truncate. No. Never mind. I'm talking shit. It's not this one that gives us the symmetry. It's this one that gives us the symmetry. If I've understood everything correctly. Truncating origin gives us symmetry. Write it up somewhere. So, okay, we create the start point and we do this in float land, so to speak, and then we truncate it, so now we're in grid land at start point. We set the current point to start point, and then we create the two primary direction, or the two directions. One primary, one secondary. Primary is the faster one, so it's just straight upwards. Secondary is the slower one, so that's up and to the left. Then we have this one here because I don't trust myself. Then we do coordinate check, so we check if x and z are equal. If they are not, we continue. We add the point to the list of points, and then we get next point, and this one we haven't changed at all, I don't think. Here we just take the point, add offset 1 to 1 point, add offset 2 to 1 point, check which one has the least radius error, and we return that one. The heart and blood of this algorithm, I would say. Then we just return the points up. I don't know, I don't see anything wrong right now, but I guess we're gonna find out. So let's see compiler errors first. Okay, great. So right now we don't have any origin offset. Makes sense. Is this correct? Yeah, and we don't have... I want to try this one. 1. Is this... Yeah, and we don't have the... We don't have the 45 degrees point because of the way our while loop is structured. So first of all, let's add the offset, so we can offset this circle, and then let's add that point as well. Adding the offset is basically just when we draw them, we just do point, or would you truncated origin truncated plus point. Nice. Okay, let's add the 45 degree point as well, and that should just be a... Then I want to do... I want to see if we need T as well. But, so it's basically going to be points. We could just create it with start point within, but yeah, let's do it like this now. Add start point. Then we calculate the next point. Although I wonder, will we get additional points sometimes if we do it? So what I was thinking is we just do this. So we calculate the next point and then we add it and then we do the check. So by doing this we will hopefully get the 45 degree one. This one. Oh, we just go up to 7. Beautiful. But will we get an additional point sometimes? Or actually, no. Like, we're relying on X and Z being the same before we quit. So we're not relying on floating point values. Nah, it should probably never happen. I'm very interested in what happens if you have an extremely small circle. So if we put the radius here, so the first point, if you only have 1 point, yeah, if you only have 1 point, then you basically have, yeah, then you never enter here. You never enter the while system, like, right? So yeah, if this radius is too small, so when we truncate it, we will get a 0, 0, 0. So when we do coordinate check, this one returns false, but we do add start point. Ooh, that's nice. Let's try it. Ah, there we go. Yeah, what the fuck? This... When we have an uneven... When we get an uneven... I want to check so I was correct with this guess at least. So 5, 6, 7... Let's see. Skull tag ellipse. Okay. And here it's good that we had the failsafe. Yeah. Okay, I wasn't even correct here actually. Yeah, because we okay, yeah, okay, if we go 4. Okay, I was correct with this case. Nice. But okay, so we have this issue. When we don't have... Yeah, when the octant is not represented by an even number or an odd number, that's when we get this issue. Let's see here. So when the octant is represented by, yeah, an odd number, then it's okay. If we have an even... that's not a way to put it either. Okay, so the assumption that X and Z... The assumption that X and Z is not the same is not true. Yeah, okay, yeah. We can do another check instead. Let's see. So while Is it while x is bigger than y? No, yes it is. Yes, doing this check was naive of me. Should have read and thought about it a bit more, but maybe I should read and think about this a bit more. But so we don't want to do coordinate check, we want to do while current point dot y is less than, or not y in our case, z current point dot x. Is this true? But I think we want to go with less than or equal. I don't know. X z. But by doing this, do we get 1 point too much? Yeah, we do. And now, let's see here. Is this the time we want to move? We want to do it like we did it previously? Or? Fuck. Or is this correct? I think this is the correct way. I'm a little bit worried about... No, I'm not. Or am I? I'm a little bit worried. Why don't we get this one here? This is where x and z are the same, right? So x is bigger than z, x is bigger than z, x and z are the same. Yeah, and that's when we need to do... So I guess we can do... have an error here, 0.5f. Would it work then? Yes, we need that error because we're working with floats once again. Okay. But that error, we need to base it on something. We need to base it on... Delta should do it, right? Or... No, then we can get a problem like that. But 0.5 times delta should do it. Or yeah, looks to be about right. Unfortunately, I think this was the easy part of it. So now we want to mirror it, and mirror it we will. But mirroring over here is easy. Mirroring over here and thereby here is also easy. I'm a little bit more worried about these, but it should be... No, we should just... No, it should be easy, it should be easy. Let's try it. Let's do... Return the points here, and then for each point we draw a sphere, and then do gizmo's color is equal to color.blue. Mirrored point. Point dot x 0.0f point dot z and let's start with minus. On X we should be seeing that one, right? And then we do yellow. Okay. Okay, so that's the easy ones. And let's see. On the other ones, we just want to flip X and Z, right? So, I don't know, orange? Do we have orange? What colors do we have? Okay. Okay. CYK RGB. So let's go with, and here we do Z, and here we do X. Wesley, you can make any color with RGB values, I think, by making a new color. Yeah, that's definitely true. I just wanna... just wanted to rely on the static ones, you know? We have magenta. And then I guess we just do minus. And then we do, let's go gray. And finally, fuck, if we don't want to go with white or black, we're gonna have to create our new color. So let's do it. What color should we do? Purple. And there. Okay, it took me a couple of days, but we're finally finally got to the correct implementation of this one. That's nice. So, let's see here. Yes. 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 No. Remove shared points. Like, the fact is that we could just add all of these points to a list, and then we can rely on link to remove duplicates, and then we can rely on link to remove, like, we can order them based on X and then Z, or we can order them by Z coordinate and then X coordinate, and then we can remove intermediate points. So we can do both of these like that. But we want this one to run as fast as we can. So I guess that is not the preferable way to do it. But we might as well start with doing it that way, get it up and running, and then we can try and figure out a smart way to optimize it. But before we do that, I'm gonna run AFK real quick again. Link is pretty fast in .NET 8 anyway. Ooh, I like the sound of that. Be right back. Okay, back. Interesting. Now we're moving on to a little bit more interesting stuff, I think. We do. Wesley, I'm not sure what your end goal is once you have the points. What are you going to change? If you set the values towards a new fixed point, it might be faster to do a couple of duplicates twice instead of removing them. Yeah, we don't need to remove them. It depends on how we solve this one, actually. Yeah. If we implement this in a good way, we might not remove them. But, so, the end goal is basically... Let's run it again. And let's see if I can visualize it better. Unfortunately, our marker is not visible in scene view, I don't think. Pause. But anyway, so this is our terrain. Runtime generated mesh. And it consists of a lot of points, and our marker is going to be placed above this point. So this is the grid we're going to work with. So we have a point here, we have a point here, and so on. And we want to get all of the points within the circle, and then we're going to alter them, send the information to everything that needs it. So altering a point twice. Now I want to skip, like, the way we want to send this onward is, but yeah, I don't really, yeah, we want to remove the duplicates, but I think it will be easy. Like, when we alter the mesh in question, we want to do it by using a call called setVertexBufferData. So we have a mesh data here with indices, so we want to tell it, like, we want to alter the mesh data, and we want to alter it from this index, and we want to alter it X. So starting at this index, we want to alter this element and the X next ones. And that's about it. What's up, DDG? How are you doing this fine Friday? Skulltag, you're trying to draw a circle on top of the landscape mesh. Not really. Like, our landscape is a height-based landscape, so that's pretty straightforward. So first we want to blit a brush mesh onto the terrain height map, basically. That brush is going to be a circle-ish. So when we do that, when we change the height map, the texture one, we actually change it in a square form. But then when we're gonna actually change the mesh data that is based on the height map, so we want to alter the vertices in height, we want to alter the vertices, and we want to recalculate the vertex normal and tangent. And instead of doing it for worst case scenario, all the vertices in the terrain patch, we just want to do it in the square where we actually made the change. And best case scenario, we actually just want to do it in the circle that we altered. So all of this full adventure is basically going to converge down to sorting out just the affected vertices, so we don't do a lot of calculations for naught, basically. DDG always doing great. Damn, that's nice to hear. And thank you for asking. Yes, I'm having a very good Friday so far. Yeah, it makes sense to remove duplicates then. Yes. But, like, the thing is, I wrote it out in these steps, but it's like I don't even think we need to. It depends on how we do this step, but this step can be pretty much skipped because let's say that we do this step by sorting all points on the Z coordinate, so then we get them sorted in rows, and then we go through each Z coordinate, each row, and take the first element. And no, let's see, we take all the points, we sort them on Z, and then we sort them on X. And then we go through each Z segment, so each row, and we take the first element and the last element. If we do it like that, it doesn't matter that we have duplicated points because they will be thrown away at that step either way. So yeah, it all depends on how we do this step. Yes. Midpoint circle algorithm tester. So let's include this extremely strong and likable thing called LinQ, I don't know. And you could probably do some cool math stuff here as well. But fuck, we could do it like this. Let's see here. Points, calculate octane points, and then we could do dot add range dot add range points. Oh, I always forget what this one is. Where can we do where? So we do points P, and here we do new vector 3 dot P dot X, P dot Y, P dot Z. So this gives us exactly the same points. Can we do this? Not I don't think it's where. Let's see. Link, do something for each element. Select. Either way, make it work first, then you can always improve on optimizations. Yeah, that's true. Select. Yeah, I think it is select. That is the go-to. Select. Yes, thank you. So we can do select. So we do add range points. For each point and first we change minus, and then we add that one. This one complains because where do we get void? This is not void. Add range. Oh, add range is void. Do we have any link function that returns the aggregate? LinQ add list to list. Yeah, but this one doesn't return the list. Or can we do... Oh, what a problem to have. 2 lines of code that much of a problem? Yes. And we want to do this like, I would like to do this like this. Let's see, add range. I would like to do this, 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 this. I would like to do it like this, I think. And then minus, and then we want to do sed, x, 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 and let's do only positive, minus, 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 and minus. So I want to do this basically. Wesley, for each p vector is equal to new vector to list async. Devioli, I'm so proud about this. Ooh, please share, please share. So this is what I want to do. Nice. I don't think there is a link version of add range. Oh, that sucks. Norin Dev, what's up? How are you doing today? Hope you're having a beautiful Friday so far. So this is what I want to do, and then I basically want to do sort. Wesley back from ads. Okay, so what you suggest is for each p vector is equal to new vector to list async. Yeah, like there's an easy way around this, I agree. And async might be a good way to do it if like we have a lot of points. But like best case scenario, I would like to link it like this, you know, link. I never thought about it, that link, that's what it refers to. I like to link my link calls, if that makes sense. Noridev, I'm good, nice to hear, nice to hear. I'm fine, I'm good as well, I'm good as well. But can we do, so actually select returns IEnumerable, add IEnumerable to IEnumerable. Concat, is that what we want to rely on? S1 concat, S2 concat. But then we need this one to return an IEnumerable, right? But let's see here, concat. Oh yeah, we need points as well. So can we do, let's start by doing this, and then we do list, yeah, all points is equal to points, and then we want to do concat here, but we need to change this one. List is IEnumerable. I think it should be as well. To list async, then you're done with your new list. Ah, yeah, that's true. Let's see. Cannot implicitly convert type. Oh yeah. So finally we just do. So yeah, here we could do exactly. But for now, let's just do to list. Okay, here we go. All points is equal to points dot concat points, where we select. Okay, this is pretty nice. So what we could do here as well is link the sorting as well. So order by, or whatever it's called. Yes, this is nice. Order by. I've never ordered by two, so let's see here. Order by link two fields. Order by, then by. Oh, I love it. I love it. So order by p dot said. So then we order it by row first, and then by p dot x. Come on. And then to list or list async. So what we have now is we have all the points making up the sphere. But we have duplicates and we have intermediate points. So let's see if we can draw this one. For each and yeah, let's just do it in red. Like, the thing is, all of this we're doing, we're probably gonna do this. We're gonna offload it to another thread later on, I think. Beautiful. Link distinct removes all duplicates. Yes, that one is nice. Love to use it. But what we're gonna do now, if we do this correct, we will remove all duplicates anyway. So basically, if we have done this the correct way, what we should have now is we have these points first in the list. So our list looks like this. It starts with this point, then this, then this point, this, then this point, and this point. Okay, so we have them row-wise, basically. What I want to do now is we want to keep them row-wise, but we want to remove... We want to keep this point and remove these three. We want to keep this point and remove that one and that one. Here we just want to keep those two. Keep. Down to here, we want to keep this one, remove that one, keep this one. Keep this one, remove that one, remove, keep. So wow, I like this song. I'm just gonna figure out what it's named and save it for future use. Okay, so we want to keep... Let's see if link... let's do... I just want to get to link documentation. Here we go. Aggregate. No. What do we have? Chunk, never used. Nah. Do we have anything here we can do except... No. Okay, that's set theory, right? Can't you do 1/2 of the circle first and just... Fuck yeah, we can. That is true. So that's... So you're saying is that we do this octate, we do this octate, then we do this octate, then we do this octate. Then we do all of this logic. So we sort them by Z, and then we just take max, and then we flip it. Damn, that's smart. That is smart. So we want to do... Ooh, what do we want to skip here? We want to... Multiple brains better than one. That is true. Let's see here. We have this octate, so we want to get this one, which is... Let's do... Let's see here. Minus, that brings us over here, right? Okay, so every octant with a minus X we don't want to keep, right? So remove. Am I thinking about this correctly? Keep, remove. No, what? How did I manage to fuck this up? Yeah. You rotated 90 degrees, the blue arrow is going left in your scene. Jeez. Thank you. Once again. So we did it the correct way. Okay, beautiful. Yes. Okay, so now we have simplified the problem. I like it. So now we want to go through each distinct Z value and keep max. So can we do it by where? Or we need... Let's see. Yeah, we could do group, right? So, like, maybe it's not the best way to do it, but we could do group by PP dot said. Or could we do it like this? So now we get a list of a list, right? Or something like that. And then we do can we flatten or something like that? Flatten link. Select many, and then we can do select many plist plist dot max p dot x, and then to list, or maybe not. Oh, that's true. Group by returns grouping. Grouping. So here we want to do PL. It's actually a P group. I want to do second or something, I thought. Grouping. Is it dot key for that one? Dot key, value. So we have key. Do we have value as well? Okay. T key element. Is that what we want? Element at. What the fuck? I just want to. No. Simura. Thank you so much for the follow. Appreciate it. Mr. P. Hi. What's the goal for this algorithm? What will it be used for? It will be used to select a set of vertices making up a terrain. So we just want to select the vertices within a circle, so we can alter just them and nothing else. Okay, so am I doing this wrong? So we group by, and then we get a list or enumerable of grouping with a key and value pair. Although float the fuck. Let's see. Group by. Do we need to do yeah, this is probably, or this is what we want, right? And okay, but I do wonder. Let's see. Just realized you don't even need to do this on a half circle. You can do it on a quarter circle as well. Yeah, that is true, right? Jesus, like, I don't know how many times we've gone back and forth here. Yeah. Like a brush to paint or deform your custom terrain. Yeah, pretty much. So, like, the actual brush we will use. It's a very simple terrain. It's just a height map in the end, or at its base, and we just want to take one brush that is a texture and apply it to the texture that is the height map of the terrain. But then we also want to alter the vertices, and this algorithm will be used to just alter the vertices affected. But yeah, it's to deform the custom terrain, that's true. Yeah, so we can just do with a square here as well. But okay, let's see here. Grouping data. Grouping A, B, C, A, B, B, B. Let's see. Let's see if I can understand this. Okay, so first of all, this should be how we do it, right? So okay. Skulltag, how much do you want to optimize this? I have some more ways. I want to optimize it as much as I can. Depends on what you mean by perfect circle, but it is symmetrical now per octant, I think, and that is much thanks to the origin snapping to the grid as well. It's never going to be Eclipse. No, I don't think so. I don't think so. Okay, let's see. Group by here. We have eye grouping, but like, so when we select many, I'm a little bit worried about this. Now this is true. So we get, okay, it's correct. We just need to get the actual list. What do we have? What do we have? We have key. Why can't I seem to get the list? What is this SQL way of writing it? What do they call this syntax? Oh well. Group by, order by. Ah, do we just need to do... No. group by dot for each group in group do something maybe. Yeah, the problem is, so select many should flatten our list. So if we would have a list of lists here, select many would flatten it, I think. Like, I would just like to be able to do something like this here. Because this one is a grouping, but I'm also a little bit perplexed here. We group them by yes. Can we do PG to list max or is it enough to just do dot max? Yeah, maybe it is. Select many, the type of arguments for method. Or can we do I just want to see here, let's see. What do they do? Group by pet age. What the fuck? Am I misunderstanding this one? Here it's like they group them by age and then name. He wants link. Fuck yeah, I do. But I don't know, group by. It's just like I'm questioning intuitively. I think, okay, so we order by Z and then by X, and then we want to group them by Z, so every element that has the same Z should be in the same group. That's how I read this. Right? And then I want to, in each group here, I want to take the maximum where X is max. So can we do... No, we can't, because now we have... Okay, let's do this. So here, at this state, we have a group. Yeah, it's basically for each I want to do, but... Okay, let's see. So what we're saying here is that we have... this is what bothers me. So here we basically have a I grouping float vector 3, float vector 3. Oh yeah, we also have a like this. And what this tells me is we have groups of a key and a value, but like I had hoped that this one was stored as a list or a IEnumerable. 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 I don't know. For each pet group, for each name in pet group. Okay, exactly. So this is very cool, but let's see here. Let me just wrap my head around this if I'm able to. Okay, let's do. So when we have this one, we can basically do for each point group, or yeah, in all points. Yeah, let's write something out here. So point group key, yeah, let's print that one, and then for each, here I want to do name. No, it's not a string, it's a vector 3. Let's do it like this. Point group vector 3 point vector 3, and this is one is actually a float, right? So debug.log point group.key, and then point Wesley, thank you. Thank you for dropping by. Thank you for the help and good luck. Let's see. What's up, Klaus? Nice. Can't you use max by? Select many max by. Ooh, let's try it. Before we continue with this one. Oh yeah, of course. And now I've changed this one. Let's do... This code is a mess right now. So what you're saying is that let's copy this one, do this, add it back, but here we do list vector 3 points, and then we do group by, select many, and it's actually let's go with g dot max by. Do we have max by? No. Possibly that's a newer function, or I don't have it. Sad face indeed. But let's see here. Like, I think this is correctly understood. So it's weird that we can't link it, or do we have an error still? Wait. Don't we print anything now? In all points. Points. Fuck. What's up, Peach? Have you figured it out? We're on the path of figuring it out. Let's see, Unity 2021 dot 2021.2 C# version. Should be. This is all the information I have. But what's more interesting is we don't print anything here. The fuck. Debug.log all points dot. Can we do length or count or size? Count. I think max by came with C#10 and Peach it's 9. Yeah, that's the. Sometimes you don't have the newest functionality. Okay, here we go. Okay, we actually draw them as well. So, and we order them by smallest to bigger. Like everything is as how we think it is, but it's just a problem by linking it. So group by here, if we could just do let's see, C# flatten group. That's basically what we want to do, right? Group by and then flatten the items. Group by, select key, you can do select after group by and treat that as an, so select P. So this is not a, like if I could treat this as I wanted it to, it's point list pl.max p.x to list, and then we uncomment this one and do this. PL is each element basically. It becomes a workaround for max by is ordered by descending. So select many group G dot order by descending first. Order by descending p dot x, so something like this, and then we get this error again, which fucks me up. Oh yeah, that's true. But the problem, like, no matter how we do this, or yeah, no matter how we do this, we always get to this. It's just, and this one showed that this I grouping wrapper. Ask GPT, maybe. We'll see. One sec. Select G order by descending. We could clean this up, right? We can just do... let's see what kind of result we get here. Fuck yeah. Beautiful. What a fucking statement this is. Beautiful. I'm gonna celebrate this one. Be right back, 1 minute. Okay, back. Sorry about that. This is great. This is what we want, right? Celebrate with a quick pee. No, unfortunately, vape. But okay, this is great. But the question then is if we can just do last. Or yeah. Okay, this is beautiful. Beautiful. It has been extremely fun as well, to be honest. Okay. Make it a quarter circle. Yes, let's do it. Let's do it. But ooh, let's see. Not used to using link. I do use link, but I love using link. Love it. But I usually don't chain more than 2 or 3 calls to it. What do we have now? If we don't count the multiple concats, we just call one concat. So 1, 2, 3, 4, 5, 6. Yeah, that's massive. Okay, let's see. Let's make it a quarter, you say. So let's do... let's add some more links to this one. So quarter, we want the first octet, and then we want to flip X and Z, so one of those two, and we want it to be positive, so it's not this one, right, and not this one. Am I thinking about it correctly? There we go. And then we want to do, let's do this. Dot concat. We want, like, the result we have here. I guess we can, to list. We could do it like this. Dot concat all points dot we can do, okay, let's just do it in a bad way first. So we do new vector 3 0.0 p dot z, and we do minus here, and then we do to list. This sucks for 2 reasons, I think. I don't know if you can duplicate the result. Yeah, that's that's what I was hoping for. So this sucks. Oh no, did I screw? All points concat all points select p. Oh yeah, and that's what we like. That's how we want it. Thank you, appreciate it. Okay, so this sucks because of 2 reasons. One, we split up the links. I like to have it as one link. I don't know why. It's pretty, feels right, and it sucks for one other reason as well. By doing this, we have 1 duplicated point. But I think I'm okay with that. Which is always the first entry in the list. Yes, so calculate octant point. Let's see. We could just where do we have the method? Oh, I could just do F12, but okay, here. Start point, we could create this one outside. Just add skip 1. Can we do skip 1? Do we have skip 1? So concat dot skip skip, is that the first one always? Or do we need to do int count skip 1? Okay, so that we can solve it by that way. That I like that one. So this should give us, actually I want to double check this, so let's do vector 3 all points 2 and a list all points 2 all points 2 yellow oh no. Yeah, we don't want to concat as well. There we go. But then you have one less point overall. Yeah, like if we don't do skip, we have this point twice. Okay, beautiful. So if we disable the red ones, we should only have these yellow ones. Great, love it. But it would be so like if LINQ supported, like when we have done all of these, if we could just continue this LINQ and do concat, and here we want the current result pretty much. Can't we do it like that? Let's see, I don't know why. Like, what we're doing here in concat, we take the result we have so far here, and then we duplicate it basically, add it to the end of the list, skip 1, and mirror it. I don't know how you do that. How do you continue this LINQ but you use the result you have so far? LINQ. I don't even know. Duplicate list and add to end. Nah, I don't even know what to search for here, but that's basically what we want to do. Or can you do all points? Nah, that's what you would like. So concat with L here, and L refers to I don't know. Duplicate. But duplicate removes duplicates, doesn't it? Oh, that's a stink. but we don't have anything. Let's do link distinct. That one removes duplicates. Do we have duplicate? Something of that sort. Oh yeah, why I want to duplicate? Because right now we only do the first quarter, or no, actually the first octant. Or no, we do the first quarter, then we get the maximum, the maxes, and then we want to duplicate it and mirror it down here, basically. So there's many steps to this one. First of all, we have an octant, and we find the pixels representing the sphere, and when we have those for one octant, we take those and we mirror them vertically and horizontally, so we get these points up to here. Then we order them by Z, then we take for each Z value we take the maximum X value, so we get all of these points. And now finally, why we want to duplicate it is because we want to take these value and flip them again, so we get the full half circle. And then we actually want to take all of those and duplicate them again and mirror them on the vertical line here, so we get all minimum values as well. And then we're done. So yeah, we can do it like this. It's just, yeah, why not? So we use points there as well, yes. Points is equal to since link returns an I enumerator, can't you just add that to itself somehow? I don't know. But so one way to do it is like this. Points concat something like this. Without making it one-line link code, you can just store the result mid-link statement and use the result somehow. So first, what we do here is we calculate an octant, then we duplicate that octant and mirror it. Then we get the max values. Then we mirror that one, and then we want to mirror it once again. Oh yeah, so don't use toList. Oh yeah, because we want to continue it. Yeah, you're true. So we should be able to do. Is it IE numerable vector 3 points? There we go. And then we skip to list, and then we skip to list, and then what we want to do as well is, so here we could do said cool. By the way, thank you so much for the follow, appreciate it. So here, maybe now you can append the content to itself. So you mean just doing this? Ooh. But the question is, when we refer to points here, is it this one or the one we have gotten up to that point? I doubt this one works. Okay, not like this. Yeah, okay, one sec. This won't work. Let's see, points. No, we got an error. So now it should work, because now we have it split up, right? And, okay, so this probably doesn't work. Yeah, it's faster at least. Yeah, we skipped the converting back and forth. That's true. Oh. Yeah. Makes sense. Makes sense. Yeah. But, to be honest, I'm fine with this. Splitting it up. I'm fine with it. But now we're gonna add one additional as well, because now I don't know how I would like to order this basically, or in what form I want to use it, but I do think I want them as pairs, but I think we're gonna do a custom struct maybe. So because I think we want some additional function later on. But let's see, public struct. Let's call it point row for now. Oops. Point row. End point. Start point, end point, and let's go this on both is equal to .x 0.0 endpoint dot set. And here we just want to do a negative here. Well, if you add the list to itself flipped, you technically have the pairs in the list based on the index. Whoa. If you add the list to itself flipped, you technically have the pairs in the list based on the index. I maybe understand you. Or get your point. Let's see here. Start point, end point. Yeah, I guess so. We'll see. We might optimize it later on when we have it in place working with the terrain. For now, let's do this, and vector 3 origin endpoint. And then I want a int number of steps. So yeah, whatever. No, not origin endpoint. Origo endpoint? I don't know. What I want to do is, okay, let's see here. Number of steps. Is equal to round we can wait with that one. Let's see. Vector 3 origo start point is equal to this one. Okay, so what I want to do here is origo endpoint minus origo start point. I don't think this should always be positive, I think. But here we want to do .x. Oh, actually, I'm making this way more complicated than it should be. That's mathf round 2.0 times origo endpoint dot x, right? And we want to take this divided by delta, but we don't have delta in here, so let's send in delta as well. This is what I want to do, I think. And then we need to cast it, I think. Let's see here. Oh, hold on. Why not just give the list as it currently is and calculate the endpoint when looping through the list, since you know it's just inverted set values. Number of steps. Oh, yeah. Yeah. Number of steps origin set times 2 plus 1. I don't know about that. Why not just give the list as it currently is and calculate the endpoint when looping through the list? But okay, let's see here. So this number of steps is pretty much number of indices that this row occupies. Does that make any sense? So if we would have been working with pixels, I could have removed this one, I think. Okay, so now origo start point with so what I want to do here is, okay, we have this one, start point is equal to origin plus this one, and endpoint is equal to origin plus end Origo endpoint. Yeah, probably want to rename these later on, but okay, so finally, we want to do, so we have points. Let's do row, what did I call it? Point row. Point rows is equal to points dot, is it select p, and what we return here is new point row p no origin truncated p and then delta and to array. And yeah, for now we're gonna keep this one here. Point, so point row in point rows. Oops. And yeah, let's red, let's do draw sphere. Point row dot start point. End point, and then I also want to I can just print it, but then I have to pair it. Okay, let's do let's just print it. So debug. Let's do it like this. For int I is equal to 0, I less than point rows dot length, and then we do row plus point row number of steps, and finally point row is equal to point rows I. Okay, should work. I hope. Great. And what do we have here? Do we have 16 rows? Ooh. Yes. It's just that they are ordered a little bit weird, but I think that's okay. But I think so. What the fuck? Just to make it easier to check if it actually works, let's do points dot order by p dot set. Right. But actually, row 0, 4, it's either this one or this one. I think we ordered it by smallest to biggest, right? So it should be this, but so we have this one, 1, 2, 3, 4. So we have the offset as well. 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Nice. So almost there. Almost. The idea is that number of steps here, we don't actually need endpoint, but number of steps here is going to be the value we put into this function here. So that's nice. The only thing we need left to do now is to convert start point here into an actual index. So that would be mesh data, and here we do start point or index of start point, index of start point, and here we put number of steps. We should be able to do it, and then we want to do that for each row. Probably gonna end with something nice in the end. So I guess midpoint algorithm tester. We're gonna go the long way around. So like there exist two solutions. Like one I know that works and one which I'm a little bit more skeptical towards. But the one that probably works is when we have all the points. So when we start creating these point rows, currently using this struct, don't know if we will use it as a struct in the end. When we create it here, we skip doing this, and instead of doing this, we do this, and then we convert it to an index based on the grid setup we have. So divide it by, I don't know exactly how it is, divide x by delta and divide z by delta, and then get the in some way, it shouldn't be too hard. So then we don't have a start point here as a vector 3, instead we have a start point as an int, and then we can just take that one together with number of steps and put it in here, finally. But unfortunately, that will have to wait until next week, because I've got to run. But productive day, productive day. So as always, I just want to say thank you so much everybody for watching and helping. Appreciate the input, and I will be back on Monday, I think. So have a great weekend. Peace.